Hi everyone, my name is Onise Tamayo and right now I'm going to talk about multi-organ and renal tropisms of SARS-CoV-2. Definition: the severe acute respiratory syndrome coronavirus 2 preferentially infects cells of the respiratory tract, but its direct affinity to organs other than the lungs remains poorly defined. SARS-CoV-2 can be detected in multiple organs, including the lung, pharynx, heart, liver, brain, and kidneys. Applications in medicine. We first quantify the SARS-CoV-2 viral in autopsy tissues sample obtained from 22 patients who have died from COVID-19. 17 patients had more than two coexisting conditions, and a greater number of coexisting conditions were associated with the renal tropisms of SARS-CoV-2, even in patients without a history of chronic kidney disease. Since the kidneys are among the most common targets for SARS-CoV-2, we performed an in silico analysis of publicly able stem cells are sequencing dataset. This analysis revealed that are from angiotensin converting enzyme 2, transmembrane cell protease 2, and cathepsin L are from genes believed to facilitate SARS-CoV-2 infection.
The COVID-19 pandemic continues to affect the well-being and lifestyle of people all over the world. It is now known that pre-existing health conditions such as high blood pressure, obesity, and diabetes can enhance the severity of the disease and people's susceptibility to infection. Curiously, however, relatively lower rates of infection and mortality have been registered in the Gulf states, where those very health conditions are extremely prevalent. A new study by researchers from Dasman Diabetes Institute in Kuwait suggests that variations in population-wide genetics could account for that disparity. The researchers compared genetic data from more than 1,300 individuals of Middle Eastern origin with those of people from Europe, East Asia, and Africa. They were looking for variations in 3 genes considered critical to infection by SARS-CoV-2, the coronavirus that causes COVID-19. These genes are referred to as ACE2, TMPRSS2, and furin. ACE2 codes for a protein receptor that makes the entry of the coronavirus into human cells possible. TMPRSS2 and furin code for proteins that facilitate that invasion. The team's analysis revealed that one variant of ACE2 that might enhance coronavirus infection was most prevalent among Europeans and significantly less common in individuals from Kuwait and Qatar. Frequencies of this variant appeared to correlate with the low mortality rates in the corresponding countries. A similar trend was observed for the furin gene. In this case, however, the team tracked a variant of furin that could possibly weaken coronavirus infection. That variant was most prevalent in Middle Eastern populations, indicating a lower risk of viral infection. Genetic variation data for the gene TMPRSS2 were inconclusive. Overall, the ACE2 and furin variants detected in this study appear to have a protective effect against SARS-CoV-2 infection among Middle Eastern populations, individuals whose general health profile would suggest otherwise. Importantly, the study did not account for country-specific factors that could affect the data. These include the extent of viral testing, socioeconomic status and access to healthcare services, and the higher burden of other diseases. The findings do appear to deliver an important message. Patient genetics deserve a closer look to understand how the current pandemic might unfold in different populations and to deliver personalized care.
Pros and cons. Pros. Quantify the SARS-CoV-2 viral load in precisely defined renal compartments obtained with the use of tissues microdossations from 6 patients who underwent autopsy. 3 of these 6 patients have detected SARS-CoV-2 viral load in all renal compartments examined, with preferential orientations to glomerular cells. Cons. We also detect viral R and protein with high spatial resolutions by in situ hybridations and indirect immunofluorescence with confocal microscopy. Renal tropism is a possible explanation for the new clinical signs of kidney injury commonly reported in patients with COVID-19.
Hi everybody, this is Fred Cartaxo. Today we're going to talk about multiorgan and renal tropism for SARS-CoV-2. In this study, the severe acute respiratory syndrome coronavirus 2 preferentially infects cells in the respiratory tract, but its direct affinity for organs other than the lungs remain poorly defined. Here, in this present data, from an autopsy series of 27 patients that show that SARS-CoV-2 can be detected in multiple organs, including the lungs, pharynx, heart, liver, brain, and kidney. In this study, the first quantifying the SARS-CoV-2 viral load in autopsy tissue sample obtained from 22 patients who had died from COVID-19. 17 patients, or 77%, had more than two coexisting conditions, and a greater number of coexisting conditions was associated with SARS-CoV-2 tropism for the kidney, even in patients without history of chronic kidney disease. The highest level of SARS-CoV-2 copies the cells were detected in the respiratory tract.
Issues apply in Ecuador. Until November 2, 2020, the Ministry of Public Health of Ecuador has reported 562 confirmed cases, 380 people died, 849 cases declared, and 476 cases with hospital discharge. This indicator updates daily reports the accumulated number of sample takings for the PCR test in authorized laboratories in Ecuador. In conclusion, our results indicate that SARS-CoV-2 has organotropins beyond the respiratory tract, including the kidneys, liver, hair, and brain, and we speculate that organotropins influence the course of COVID-19. This is impossible aggravates pre-existing conditions. Thank you.